Hey there, Year 11. So in this question here, Chapter 5, Functions and Relations, 5H question 4, here it says, a piece of wire 100 centimeters long is bent to form a rectangle. Let x centimeters be the width of the rectangle. So I would draw the rectangle to start off with. So we have a nice rectangle. This has a length and it has a width. And it says that you're going to let x centimeters be the width. So I'm going to call this x centimeters. And we don't know what the length is. But part A, in question A, they want you to find the length of a rectangle in terms of x. So in this case here, what we know is that width is x centimeters long from here to here. And it also tells us that from here to here is also x. We don't know what length is, but we'll call it L for now. So let's just call that L. Now, we know that this rectangle was made up of 100 centimeters of wire. So what that means is that if you added all of the lengths together, it should add up to the piece of wire, which is x plus L plus L should give you 100 centimeters. Okay. So from here we can say it's 2x plus 2l is equal to 100, and our job, or what we're looking for, is to find the length in terms of x. So what that means is you're going to try to solve for L and then isolate L and in terms of x. So here I'm going to say subtract 2x on both sides. 2x minus 2x cancels out. You now have 2L is equal to 100 minus 2x, and you can see here, dividing both sides by 2, dividing every single term by 2, and you get 2 divided by 2 cancels out. L is equal to 50 minus x. So that now gives me the equation for the length in terms of x. In part B, note that when it comes to these exercises, you're doing 5H, in this case it's an application type problem, you are allowed to use a calculator. So I'd probably start off with my calculator by defining the function. So here we go, we're going to define the function. What is this? Here we go. We're going to start off by defining the function. So here we go, I'm just going to minimize this. We're going to say menu 1, 1. We're going to define the function f of x is equal to, actually we haven't got the function yet. Sorry. Let's go to part B and then we'll get the function. So part B says that we need to find the rule for A, which is the area function that gives the area of the rectangle. Now we know that the area of rectangle is given by length multiplied to width. So we know the length is now 50 minus x, so 50 minus x multiplied to w, which we knew was x. So this gives us the area equation where it's x times 50 minus x. Correct? Okay, so that's probably what I would write on my calculator. I would define f of x equals to x multiplied to 50 minus x, press enter, and I've defined my function. Okay, part C says find the allowable values for x. So what does that mean? What they want you to recognize is that x represents the width. So there must be, and that's in centimeters, there must be certain values that x cannot be possible or is not allowed. And logically, we know that the width cannot be negative. So width cannot be negative. So that means where on this graph, on this function, will it not make sense anymore? And so the best way to do it is actually to sketch the equation and have a look at the function. So here we go, I'm going to do control, add a page, put on a graph, and I'm going to put in f of x that I've defined. Need to adjust the window, menu, 4, And let's see if zoom fit can fit the data. So no, I can't really fit it. So I'm going to have to adjust it manually. And I'm going to go to menu 4 for Windows and then settings, number 1. So I'm going to adjust it horizontally. I'll probably go up to maybe about 60. And I need just a bit further up. So menu 4, 1 again. And the maximum Y value is 500, but let's say we do 700 this time. And there you go. I can see the graph much better now. And I need to know, clearly the x-axis, which is the width, cannot be negative, so I shouldn't be sketching anything from the negative side onwards. And I know that area doesn't make sense to be negative, so there must be between these two x-axis intercepts. So I'm going to go menu 6, 1, and here we go. We've got first x-intercept. I'm going to try another one. And we can see that we now get 50, 0. So I'm going to just copy this page just so that you can see. Here we go. Let's analyze this together. I'm going to paste it here. I'm just going to move it across. Okay, so we now know we cannot sketch this part of the graph because that side there's negative area, but also because that's negative x length, and down here is negative area. So really the only part you can sketch is from 0, 0 all the way up into 50. So in terms of the allowed x values, we know it clearly starts off 0 and it stops at 50. So answering this question here, I would then say x is an element of inclusive of 0 to 50. Okay, technically I would argue that you probably can't have 0 and you can't have 50, because if you did, then the width wouldn't make sense. You wouldn't have a rectangle. So to have a rectangle, it has to be greater than 0. But I have a suspicion that the solutions in the textbook would say equals to 0. Okay, and then part D, they ask you to find, in this case here, you're to find the maximum possible area of the rectangle and the value of x for which this maximum occurs. So really, on your graph, we can now go menu, analyze the graph, and we can say, let's find the maximum. So I'm moving across, I'm selecting 1 point, and then I go to the right of where I think the maximum is, and you can see I now have the maximum, or turning point, part of my question. So now I know the maximum y value, which represents the area, whilst this represents x, which is the width. The maximum area I can get is when the width is 25 centimeters and the area is 625 cubic centimeters. Okay, so to answer the question there, find the maximum possible area of the rectangle. Well, I know the maximum area max must then equal to 625 cubic centimeters, whilst the what's the other one? It says then find the value of x for which this maximum occurs. Well, x is the width, and x at maximum, and when the area is maximum, I shouldn't write x max, it should just be x. If I just write x,